Okay, so part 2 in part B, it's asking us to calculate the height of the object above the ground 4 seconds after it was dropped. So if we get this situation drawn up again, right? Remember now, this object is dropped at 160 meters, top of a building. Okay, and the initial speed it's dropped at is 0 because it's dropped from rest. Okay, and we want to know where it is after 4 seconds. Okay, so when t equals 4, where is it? But when we work out where it is, obviously we're going to calculate what s is. Okay, just remember when we calculate s, s will be this distance measured from the top of the building. Yeah, because remember where we start from is where we start measuring displacement from. So s is measured from the top of the building, right? And we take downwards as positive, don't forget. Okay, right? So suppose it ends up here after 4 seconds, when t equals 4. We would have worked out this distance. That would be my s. But at the end of the day, they're asking, aren't they? They're asking for how far off the ground it is when t equals 4. So that's something to think about in a minute. So t equals 4, we want to find out s. Is, remember, the initial velocity is 0, and now this time the acceleration is not going to be as we had in part A. Remember in part A, the acceleration was 9.8 because it was falling freely under gravity. Okay, nothing else was influencing it, so A was just the gravity value. Now there's a resistance. Remember I said because there's a resistance, the acceleration won't be so much. The acceleration is actually 5. Okay, so it's not going to be so much now. It's a lot less than 9.8 because of this resistance here. Okay, but we can use the equations of motion to work out what s is. Okay, so if we use s equals ut plus half at squared. Okay, so remember u is 0. Okay, so that goes. So I have half times acceleration, which is 5, times time, which is 4, and of course square it, and we get that basically. So let's work that out. And I get 40 meters. Okay, but remember that isn't my final answer. 40 meters is just measuring this distance from the top of the building. So to get the height above the ground, we need to do the full 160 meters of the building. All of that, take away this 40. I know my diagram isn't drawn properly to scale, right? That doesn't matter. Just for you to see what's going on here. After 4 seconds, it's fallen 40 meters basically. It's fallen 40 meters after 4 seconds, which means it's got another 120, isn't it, to go. So that's the answer I'm looking for. Okay.